Rational Expressions, Chapter 11, Test Review. Okay, simplifying expressions. We are going to have 5 questions on simplifying expressions. Two questions which are asking for the domain or the excluded values. And 3 questions on simplifying. Okay, let's look at some examples. So this one says to find the excluded value. So the excluded value, or the domain, is the value in which would make this equation not true. It wouldn't work. So we need to set our base, our denominator, equal to 0 and solve. So I am only looking at the denominator. So I'm looking at x squared minus 3x minus 10. So I'm going to factor this. Two numbers that multiply together to equal 10, negative 10, and add together to equal negative 3. So I have x plus 2 and x minus 5. And we're going to set this equal to 0 and solve. So x plus 2 equals 0 and x minus 5 equals 0. So my x equals negative 2 and x equals 5. So this means that my excluded values, or my domain, is all real numbers except for x cannot equal negative 2 and 5. Because if you were to place this into this equation, your denominator would equal 0, and that would not work. Okay, now this one is asking for us to simplify this expression. So I'm going to look at my top. Can this be factored? Yes. It's a perfect square binomial. So it can be factored to x plus 2 and x minus 2. Okay, can my bottom be factored? Both of them have an x. So yes, I'm going to factor out an x. So I'll get x minus 2. Okay, if there's anything that's on top that is the same on the bottom, we can cancel them out. So I am left with x plus 2 on top and x on the bottom. I gotta pause this. Okay, let's try another. So this one's asking for us to simplify the expression. Oh, we already did this one. Okay, so this one's asking for us to simplify the expression. So I have 4a plus ab over 6a. Okay, so I want to look at my top here. Is there a value or a variable that can go into both 4a and ab? A. So I can factor out an a. So this becomes a, parentheses, 4 plus b over 6a. Then my a's can cancel out. So that leaves me with 4 plus b over 6. Okay, let's see what else is going to be on our test. So we're going to have 7 questions on multiplying and dividing rational expressions. 3 questions on multiplying, 3 questions on dividing, and we're going to have 1 complex fraction. Okay, so in this case we are dividing. Remember, when we are dividing 2 fractions, we keep the first term, we change the sign from division to multiplication, and we flip the last term. So I'm going to keep, change, flip. So I'm going to have 12x squared y over 5y squared. change my sign to multiplication, and flip. So I'll have 2xy over 3x squared. Okay, so now I'm going to multiply out this equation. Because they're all monomials, it's easier to do it this way. So 12 times 2 is 24. X squared times x is x to the third. Y times y is y squared. All over 5 times 3, which is 15. X squared, y squared. Okay, now we are going to reduce or simplify. So 24 and 15 both can be divided by 3, so I can simplify it, and it will become 8 over 5. And then I can subtract here, or divide my variables, which I have my exponents will then subtract, so this becomes x, and then my y's cancel out. So my answer is 8x over 5. Okay, this multiplication problem. So I have binomials here, so I can't do this in which I multiplied out. I'm going to have to factor. So I'm going to look at my top part here. Okay, so I have 3x squared minus 12. What number or variable can go into both? 3. So I'm going to factor out my 3. So this becomes x squared minus 4. Okay, this should look familiar. We did this earlier. So we're going to come back to that though. So we have 5x minus 10. I can factor out a 5. So this becomes x minus 2. Okay, so my 1 is going to remain 1. Okay, so now I have 2x plus 4. I can factor out a 2. So this becomes x plus 2. Okay, so now let's come back to this x squared minus 4. Remember earlier we factored this by because it's a perfect square binomial. So it would be x plus 2 and x minus 2. Okay, now we're going to simplify. Anything that is the same on top and bottom, we can cancel out. So I have an x plus 2 and an x plus 2, an x minus 2 and an x minus 2. So I'm left with 3, 1, 5, and 2. So now I can multiply 3 times 1, which is 3, and 5 times 2, which is 10. So my answer is 3 over 10. Okay, so this is a complex fraction. So whenever you have a complex fraction, you have a fraction over a fraction. This is the same as dividing. So this would be the same as x plus 2, or x plus 1 over x squared minus 1 divided by x squared plus 2x plus 1 over x squared minus x. And in order to divide here, we can keep, change, flip, just like we did in the first problem on the slide. So I'm going to keep my first term, x plus 1 over x squared minus 1, change my sign, and flip. So I'm going to get x squared minus x over x squared minus 2x plus 1. Okay, now that I've keep, change, flip, I can reduce. Now I'm back to just like our second problem here. So I'm going to look at my top here in x plus 1. I cannot reduce that. Okay, what about x squared minus 1? I can redo this. It's a perfect square binomial where we have subtraction. So I'm going to have x plus 1 on top, and this becomes x plus 1 and x minus 1. Okay, I can factor out an x. So that becomes x minus 1. And here I can factor, I need to find two numbers that multiply together to equal 1, but add together equal positive 2. I accidentally wrote that incorrectly. So that would be 1 and 1. So this becomes x plus 1 and x plus 1. Okay, now I'm going to cancel out anything that is the same on top and bottom. So x plus 1, x plus 1.
Could Coach Elliott or Coach Lau?
Okay, So I cancel out my x plus 1 and my x plus 1. So I have an x minus 1. I can cancel that out. So I am left with x over x plus 1 and x plus 1. Okay, whenever we have two of the same things, what is it? Yes, it's x, it becomes squared. So our answer is x over x plus 1 squared. So that is multiplying and dividing rational expressions. Now we're going to go into dividing. Polynomials. We're going to have 5 questions on dividing polynomials. One in which we're dividing a monomial, or dividing by a monomial. One in which we're using, or 3 in which we're using synthetic division, and 1 in which we're using long division. Okay, so this one, whenever we have a binomial at the end, and it's the x by itself, we can use synthetic division. You can use it with all binomials, but this one is the easiest way to do it. And we're going to use synthetic division. Okay? So I'm going to place my coefficients of my dividend inside my synthetic division box. Each term needs to be represented. So I have an x to the third, which has a 1 out front, so I'm going to have a 1 there. I am missing x squared, so it's going to be 0. I am missing x, so it's going to be 0. Then I'm going to have negative 8. Then I'm going to set my dividend equal to 0, and that is going to be the number that's on the outside. So it's going to be x equals 2. So 2 is going to be on the outside. Then I'm going to bring down my first term. Okay? Then I'm going to multiply my outside term by my first term. So 2 times 1, which is 2. Then I'm going to add. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. Negative 8 plus 8 is 0. Okay. So then you're going to look at your highest degree, which is 3. Your first term is going to be 1 less degree. So this will be 1x squared or x squared. Plus, then we do the next one, 2x plus 4, which that is my answer. Okay, so in this case, this is a monomial, okay? So it's one term. So you're going to divide each term by this one term. So I'm going to have 2x to the 4th divided by 2x squared plus 4x divided by 2x squared minus 6 divided by 2x squared. Okay, now we're going to reduce, okay, or divide. So 2 divided by 2 is 1. X to the 4th divided by 2x would be x squared. So this would be just x squared. Okay, 4 divided by 2 is 2. Okay, x divided by x squared, it's going to be negative x. So that is going to be, remember when we have a negative, it brings it to the bottom. So that's going to be 2 over x. Okay, 6 divided by 2 is 3, so negative 3. Okay, I can't divide my x squared by anything, so this is just going to be x squared on the bottom. So my answer is x squared plus 2 over x minus 3 over x squared. Okay, long division. So in long division, this is just like long division from when normal long division. So except for we're going to have some variables. So I'm going to set up my dividend and put it inside of my division. Then I'm going to place, now we have more room. Now I'm going to place my dividend on the outside. Okay, now I'm going to just, basically this is like normal division. So I need to figure out what I can multiply 3x by to get to 12x to the third. Okay? Yes, that is correct. 4x squared multiplied by 3x would give me 12x to the third. So 4x times 3x is 12x to the third. 4x times negative 4 is negative 16x squared. Then we're going to subtract all of this. Okay, so basically we're going to be distributing our negative sign and then adding. Okay, so 12x to the third minus 12x to the third cancels out. Okay, 11x squared plus 16x squared would give me 27x squared. Then I'm going to bring down my next term, negative 15x. Now I need to figure out what multiplies together to 3x to give me 27x squared. Okay, yes, that is 9x. 9x times 3x is 27x squared. 9x times negative 4 is negative 36x. Then we're going to subtract, so I'm going to distribute my negative sign and then add. Those cancel out. Negative 15x plus 36x is going to give me 21x. Going to bring down my 8. Okay, what number multiplies together 3x to give me 21x? That is 7. So 7 times 3x would be 21x. 7 times negative 4 would be negative 28. Okay, then we're going to subtract. So I'm going to distribute my negative and then add. Then I'm going to cancel those out, and then I am left with a remainder of 36. So when we used to use long division to divide numbers, we would set our remainder over our divisor, and it's the same thing here. So I'm going to plus 36 over 3x minus 4 is my remainder. So my answer is 4x squared plus 9x plus 7 plus 36 over 3x minus 4. Okay, so the remainder and factor theorems. So we're going to have 4 questions on this. 1 on the remainder theorem and 3 on factor. Okay, so it says if, or f of x equals x to the third minus 2x squared plus, or minus 4x plus 1, find f of 2. So we're going to use synthetic division here. So inside my synthetic division box, I'm going to put each one of my coefficients. So I'm going to have 1, negative 2, negative 4, and 1. Remember that you need to make sure that every single value is being represented, every single degree. Then I'm going to put 2 on the outside. So this is already set up for you. So this is the same as like x minus 2, which is just 2. Then I'm going to use synthetic division. So I'm going to bring down my 1. 2 times 1 is 2. 0, 0, negative 4, negative 8, negative 7 is my remainder. So in the remainder theorem, negative 7 is my answer. Now let's try some factor theorems. So it says is x plus 3 a factor of 4x to the third plus 2x squared minus 3x plus 81? So in this case, I am going to use synthetic division to figure this out. So I am going to put my coefficients on the inside. So I have 4, 2, negative 3, and 81. Okay? Then I'm going to set my factor equal to 0, which this would be negative 3. So negative 3 would go on the outside. I'm going to bring down my 4. Negative 3 times 4 is, negative 12. 2 plus negative 12 is negative 10. Negative 3 times negative 10 is 30. And negative 3 plus 30 is 27. Negative 3 times 27 is negative 81. So that is 0. If your remainder is 0, that means that this is a factor. So the answer here would be yes. Okay, so this one's asking us to completely factor x to the third plus 9x squared plus 23x plus 15 if x plus 5 is one of the factors. So we're going to be doing the same thing that we did beforehand using synthetic division. However, now we are looking for all of the factors. So once I am done, I'm going to write my quotient and then factor it. So let's start off by writing my synthetic division box. Okay, and then I'm going to have 1, 9, 23, and 15. Okay, then I'm going to have my negative 5 on the outside, because remember we set this equal to 0. Bring down my 1. Negative 5 times 1 is negative 5. 9 plus negative 5 is 4. Negative 5 times 4 is negative 20. So I'm left with 3. Negative 5 times 3 is negative 15. So that is 0. So yes, this is a factor. However, now I need to set this up as an equation. So I have x, or quotient. So x squared minus 4x, or plus 4x plus 3. So now I need to find two numbers that multiply together to equal 3, that add together to equal 4. So those would be x plus 1 and x plus 3. So all of my factors are x plus 5, which that was given to us, x plus 1, and x plus 3. Okay, graphing rational functions. So there's going to be 4 questions on graphing rational functions, 1 in which you're finding the center and 3 in which you're graphing. To find the center and graph. So the center is always going to be your k, h, the opposite sign, and your k. So in this case, my center is going to be 2, 1. So now that we know my center, I can find my vertical asymptotes and my horizontal asymptotes. So my vertical asymptote is x equals 2, and my vertical asymptote is y equals 1. So our graph will never cross x equaling 2 and y equaling 1. Okay, so let's look at how that would look. So I'm going to draw my little graph. Okay, so my vertical asymptote x equals 2 would be here. So my graph I know is never going to cross there. And 1. My graph is never going to cross there. Now I need to find where my branches are going to go. So I'm going to create an XY table. Okay, so now I'm going to substitute values in. I want to pick values that are around my asymptote for x. So I'm going to pick, in this case, x is at 2, so I'm going to pick 1 and 3. So you want to pick them on either side, 1 and 3. So 1 over 1 minus 2 plus 1 equals negative 1 plus 1, which is 0. So this point's going to be at 1, 0. So this branch is going to approach my horizontal asymptote but never cross, and approach my vertical asymptote but never cross. So I do know that my other point is going to be on the catty corner of this point. However, we still need to solve. So I'm going to have 1 over 3 minus 2 plus 1 equals 1 plus 1, which is 2. So this point is at 3, 2. So again, this is going to approach my vertical asymptote but never cross, and approach my horizontal asymptote but never cross. So that is graphing rational functions. You do have a practice test in which you can work on, and if you have any questions, you may come see me in the morning.